Hello out there, welcome back. So we're still on tree diagram and we're focusing on probability, okay? So it's very useful to represent a probability situation using a tree diagram, especially if you have lots of outcome. I mean, if I flip a coin once, easy to deal with it. But if I flip it twice or three times, very useful to solve that problem using a tree diagram. Okay, so now let's look at a question where we're going to draw a tree diagram, and after drawing a tree diagram and solve some of the question. Okay, fantastic. So a tree diagram can be used to help solve problems involving both dependent and independent events. That's very important. It can solve independent and dependent events. So the following situation can be represented by a tree diagram. Let's read carefully. Tabo has 10 colored cubes in a bag. Okay, very important. 3 of those, I'm underlined, 3 of those cubes are red. Okay, if 3 are red, I mean 7 should be what? Blue. Because we have 10 cubes in a bag. Are we together? And what we know is that 3 are red and 7s are blue. Fantastic. What does Tabo do? He removes a cube at random from the bag and note the color before replacing it. Very important, before replacing it. So what he does, we have 10 cubes in a bag. What Tabo does, put your hands in a bag, replace, take out a cube, and you look at the color, and you'll put it back. So with replacement. So he replaced it back. Okay? And I want you to think about also, what if he doesn't replace? What happens? So he's replacing now. Okay. Will it change probabilities and stuff? Will this change the tree diagram? How would it look like? Okay. So let's see. Then he chooses the second cube at random. Use the tree diagram to determine the probability of all different outcomes occurring. Interesting. It's not easier than a coin, because a coin, my outcome is tail or head. We together. Now we have a situation, we have a bag with 10 balls inside, and we know that how many of them? 3 are red and 7 are blue. Take a ball, put it back, take a ball, put it back. Draw the tree diagram and show the possible outcomes. What is an outcome? We could get blue. Put it back. We could get blue again. Put it back. Or we can try. We get red, we put it back, we get blue. Those are the outcomes we can have. Let's see how a tree diagram looks like. Okay. So Tabo has 10. He has 10 colored cubes in the bag. Very important, 3 of the cubes are red and 7 blue. So we have 3 red, okay, and 7 blue for blue. He removes the cubes at random from the bag and note the color and replacing it. Very important, you replace. Then he chooses the second cubes at random. This means the 2 events are independent. Why do we say they're independent? Me getting red first will not affect the chance of me getting blue the second. Why do you think they're independent? Any idea? Why is this independent? Because I'm replacing back. The sample space will stay the same. Are we together? Because I'll still have 10. If I draw blue, I have blue, I see blue, I put it back, I'm back to the original setup, which is 10 balls in a bag. But now if I don't replace, and I put it away, that's a different scenario. Because now I won't have 10 balls anymore, I'll have 9 balls altogether. Okay, so this is an independent event because we are replacing. So let's see what we get. So the first choice will have a red. There's a red. What is the chance of getting a red? How many red balls in a bag? We have 3 red balls. What is the sample space? 10. So the probability will be what? 3 out of 10, which is 0.3 or 30%. Okay, so this is what we get. We could get red or blue. The probability of red is 3 out of 10, and the probability of blue is 7 out of 10. So this is your tree diagram. You put a line like that and a line like that. That's the first. Because the probability of getting red is 3 out of 10, of getting blue, 7 out of 10. Why 7? Because there are 7 blue balls in a bag, and there are 3 red balls. This is what we do for the first time. And how many times we do this twice? It states he then chooses a second cube at random. Then we're going to choose another one. We replace and we do again. What do we get? For second choice, we can still get red or blue. Doesn't matter. I'm getting red. I'm getting red for the first time, but I replace it. I can still get red. Or I can get blue. What about the probabilities? Will the probability change? No. Because I'm replacing it back, I still have 10. I still have 3 blue, 3 red. I still have 7 blue. Nothing has changed because I'm replacing it. So what it means, and for the second part also, if I get blue and replace it, if I do it the second time, I can still get red or blue. I can get red or blue, and what are the probabilities? The probability of red is 3 out of 10, and the probability of getting blue will give us what? 7 out of 10. And what about the probability of red? Still the same, which is 3 out of 10, and the probability of blue also is still 7 out of 10. Are we all together? I'd like you to look at something here. What does this number plus that number add up to? Can you see that? 3 out of 10 plus 7 out of 10. We call those the branches of the tree. 3 out of 10 plus 7 out of 10. Can you see that add up to 1? Yes. Let's go to the second branch. Again, 3 out of 10 plus 7 out of 10. What do we get? We get 1. Also here, 3 out of 10 plus 7 out of 10, we get 1. Are we all that will always get up to 1. Are we all together? Okay. So let's look at the possible outcomes. Red, red. We'll get the probability of red being red. We have to multiply the branches. 3 out of 10 multiplied by 3 out of 10. So the probability, P means the probability of getting red and red is 3 out of 10 times 3 out of 10, which is what? 9 out of 100, which is 9%. What is the chance of getting red twice? The same question. Okay. Now let's look at what is the chance of getting red followed by blue. So it implies if you get red followed by blue, this is what we'll get. We'll get red followed by blue. What is the probability of red? Red is still 3 out of 10, then followed by blue. What will that give us? 3 out of 10, agreed? Times 7 out of 10, which is 21 over 100. Fantastic. Then the likelihood, probability of getting blue followed by red. The chance of getting blue followed by red will give us 7 out of 10, because we're getting blue, then red, which will give us what? Probability of blue, then red. What is the probability of getting blue? 7 out of 10 of getting red, 3 out of 10. We get 21 over 100, which is 21%. The chance of getting blue is what? 7 out of 10 multiplied by 7 over 10, which is what? Which is 49 over 100. Just 49%. Okay, fantastic. Now, let's look at this. This is the tree diagram complete. We drew tree diagram, which is our first choice there, second choice there. What does this represent? So the end and the first level of the branches shows the different outcomes. Are we all together? Then the probabilities of each event are shown along the arm of each branch, and they add up to 1. That add up to 1. We all together. And lastly, because the events are independent, the probabilities must be multiplied along each arm. You multiply that and that to get the actual probability. For now, we'll take a short break and we'll see you shortly.